Hello everyone. So in the last video we web scraped some reviews of money heists from the IMDb website using Selenium. And we created a data set of reviews and labeled them as either positive or negative based on star rating provided by the users. So in this video we'll be creating a sentiment analysis model based on support vector machines, and that model will be able to classify that whether any new review that comes in, whether it is positive or negative. So we need to understand what sentiment analysis actually means. So sentiment analysis is the process of determining whether a piece of writing is positive, negative, or neutral. A sentiment analysis system for text analysis combines natural language processing and machine learning algorithms to assign weighted sentiment scores to the entities, topics, themes, and categories within a sentence or a phrase. So in layman terms, what it means that the classifier will learn, like for example, if there is a negative sentence and in most of the reviews dislike word is used, and the tone that the label of that review is negative, so it will learn that dislike word carries a negative essence, so it will assign a high negative weight to the dislike word, right? So it will identify these type of words and assign weight based on their usage. Okay, so sentiment analysis helps data analytics within a large enterprise gauge public opinion, conduct nuanced market research, monitor brand and product reputation, and understand customer experiences. So you need to understand that like a machine or classifier does not understand words or text like we humans do, right? So basically what the machine understands is words, or to be precise, vectors. So we feed vectors which are equivalent, which are number or machine equivalent entity of a text. So we feed those numbers or vectors into the classifier and they learn from those vectors. So the first and the utmost part that we perform in NLP is data preprocessing. So the first task that we do is remove stop words from the document. So stop words are basically I, me, or, are, you, etc. So the reason behind removing the stop words is like these words will be used in all type of sentence, whether it is positive or negative. So I cannot use them as a feature to classify whether if I am using I, so whether this is a positive or negative. I can't, right? Because they don't actually define they don't carry the actual meaning of the sentence. For example, I want to convey to you that I went for a walk in the park. So I can just say I went, walk, park. So you'll still be able to get the gist of what I'm saying, right? The next thing we do is change the case of the letters to either uppercase or lowercase so that our features are uniform and the whole corpus is uniform. The next thing we do is stemming and lemmatizing the words, right? So we convert the word liked to its base or the root word like, because liked and like carry the same meaning. So I don't want my algorithm to compute extra weights for the word liked and the word like, because they actually have the same effect. So I don't want to increase the number of my features, because if the word liked is also occurring many times, if the word like is also occurring many times, I will have to calculate weights for both of them. So that will be just extra computation for my classifier. So there's something called bag of words model, which we will be creating using the count vectorizer. So just look at this table. So document 0. So in our use case, the document 0 will be the first review. Document 1 will be the second review. Document 2 will be the third review. And these are some words, like after all this processing, I've come up with these words, and these are the words that occur the most in our reviews. For example, I look at all of my reviews and find out some amount of words, let's say 1500 words. I find out 1500 words that occur the most. So our contextual meaning of the words, whether they are positive or negative, depends on these 1500 words, right? So let's say if the word occurs, for example, with respect to first review, if the word at occurs 0 times, so I'll write 0. If the word 4 occurs 0 times, I'll write 0. If the word 2 occurs 1 time, 1. geek1, geeks1, and if the word geeks occur 2 times in my second review, I'll write it as 2. So basically, I've created a vector. Like I previously mentioned, the algorithm doesn't understand text or words, right? So we have converted this text into a vector. Vector is basically a n-dimensional matrix. So let's just look at this first column. Okay, so this has, let's say if I take 1500 words, so there will be 1500 columns, 1500 features, and there will be one row. So it will be a vector of 1500 dimensions. Okay, so and then I'll feed into my classifier. So it will learn ki okay, I use the word at with each, sorry, if I don't use the word at, but if I use the word geek and geeks and helps, so it will be positive. And if I use the word some, let's say dislike 3 times, the effect will be negative. Or either it also, if it also conserves the correlation between two features. For example, if this word is not, if this word is used with this word, then the result is positive. So basically it finds the correlation between each word key. What is the effect if this word is used with this word? What is the effect on the actual label, that is whether it is positive, negative, or 1 or 0. So basically it conserves some insights, it learns some valuable insights, and it doesn't just learn these insights from one review. It learns from all the 2000 to 3000 reviews that we have in our data set. And this knowledge that it has preserved basically are the weights. So for example, this at word is very common, right? It can be used in either positive review or negative review, so it will be a lower, it will assign a lower weight to this. But if there was a word like, and it is used consistently in the positive reviews, it will assign a higher positive weight. Okay, so based on these weights, it will classify any new review. Yeah, first of all, when a new review comes in, it will convert it to a count vector. It cannot just input the word directly into the classifier. We'll have to first convert the count vector based on our corpus of reviews, and we'll create a count vector and then insert into our algorithm classifier, and will again look okay, this word is used with this word, this word is used with this word, and the word like is missing, the word dislike is present. So yeah, okay, we'll classify it as negative. So let us start off with importing our libraries. First we have NumPy, then pandas. So NumPy will be used for matrix operations, and pandas will be basically used for importing our dataset, and will be pre-processing our reviews. So we'll be using the regular expressions library in Python, and this is a new library called NLTK, and this library will be used for our natural language processing tasks, like creating the count vector, removing the stop words. So we need to first download the list of stop words and include it, import it. And for the stemming or lemmatizing part, like I mentioned previously, we stem down the word liked to like, so that because they both carry the same meaning, and we don't want to increase the number of features unnecessarily. So we include this class, porter stemmer. So let's start off with importing our data set. So we are using a TSV file, not a CSV file, because the reason behind using our TSV file is the full form of CSV is comma separated values, but in the sentences we already have comma, so we cannot use a comma as a delimiter. So let's say this text column, this data corresponds to this text column. Okay, if I were using a CSV, so all of the data which is after this column will go to the sentiment column. So that might confuse our pandas library, the read CSV function, and it would include this all into this sentiment, but we don't want that. Sentiment is basically a label 1 or 0. positive or negative. So I'll mention a delimiter here, that is escape character of tab, and we need to pass an argument called quoting. So basically what will quoting do is remove these unwanted quotes, because we want a clean data. Now this might happen where the text, these reviews are missing, and since we will be applying some string operations for a pre-processing, we cannot apply the string operations on null values. So we need to eradicate those null values from our data set. We need to basically eradicate the whole row where the text value, where the value in this text column is null. So basically I will find out I'll first get my text column and find out all the values which are not null. Okay, which are not null, and this whole operation will, what it will do is basically query out the rows in which the value in the text column is not null. So it will not just return the text column, it will return the whole row, right? And now since we are removing some rows, the indexes might get removed. Like if I remove the second review, the indexes would be like 0, 2, 3, 4. So I don't want that. I would want my indexes to be consistent and uniform. So I'll write this function called reset index, which will basically reset my index. So here I have first two parameters, which is in place equal to true. So in what it will do is, it will not just return a resetted a new data frame. It will do the transformations or reset the index in the already existing data frame. Okay, and a drop equal to true will drop the previous index, the previous index column. So I'll just run it. And in the variable explorer, we can see our data set. So basically there are four columns, that is rating, title, text, and segment. Here you can see the shape, and I have 2055 rows. Okay, so let's start off with the pre-processing. So first I'll define a list called corpus. So corpus is basically will contain the list of all my processed reviews. The reason we call it a corpus, because corpus is basically a data of language, and that corpus can be used for many tasks, and one of them is sentiment analysis. So I'll iterate over all the reviews. So I'll go from range 0 to the length of the data set. The length is basically 2055, and the second argument in the range operation is the upper bound, and it is not considered. So we'll go from 0 to 2054. So the first thing that we need to do is remove unwanted characters, right? So for that we'll be using the regular expression library. So I'll enter a regular expression here. So what I have done here is like written a regular expression which says if any character in this review, in the first review, let's say we are at the first index, 0th index, and if any character is not a letter, either capital or small, this is basically an OR. So either capital or small. If it is not, this is basically a This is basically a symbol for not. Okay, so if it is not a character, if the character is not a letter, then I'll replace it with an empty string, and I'm going to apply this rule on the text column. Basically, I'll fetch the column using text, and basically on the ith index of that column, or the ith review. Now like this is basically done because, as we can see here, there are some emojis and some commas and some, yeah, here some, these are basically Unicode, so I want to remove them because I cannot use them as a feature key, whether like as a feature, as one of my features to classify whether it is positive or negative, the review. So now I'll lower down the case. You can either upper, you can use upper also, but the main reason behind it that it should be uniform. So yeah, I've splitted the data set, I've splitted my review. So this split function, basically what it does is that it takes in a, we apply this on string, and basically what it does is it will return a list of all of the words in my string. So we, by default, this split function uses an empty space as a separator for the words. So if the words were separated by a comma, let's say there, comma is, comma a, comma dog, and I splitted this using a comma, so it would just give me a list of words. By default, it's an empty string. So I'll be using something called list comprehension for removing the stop words as well as stemming them down. So first I'll write the basic syntax. Basically what we are doing is iterating over the review and getting this, at each iteration we get the word that is in our list of words, that is review, and we append it into the list by initially just writing it here. But we don't want to just write it down like that. It would be same as the review list, so we'll stem it down. So PS is basically an object that will create out of the port stemmer. So let me just mention here. And we'll stem it down. For example, the word was liked, it will stem down to like. Okay, and I want to check whether the word is in my stop words or not. If the word is in the stop words, then I don't want to add in my list. See, like I said, there are many stop words in many languages, so we are focusing on English language. And here I mentioned a if condition, like for first the logic will be for word in review, so we'll get the first word and check whether the word is in set or whether the word is in the stop words list or not. If the word is not in the list, then only we'll stem it down and append it in our list. But if the word is in a stop words, we'll skip it and move to the next word. The reason behind that, I've used a set data structure, because set is basically a data structure in Python where it's basically like a list, but it does not accept duplicate values, and the searching happens faster in my set. Basically, I'm searching my word in a list of stop words, so I've used set because the searching happens faster. And now we'll have to, as of now we have a list, but we want a string back again. So basically I'll use a join operation. So join operation is basically the opposite of split. Like in a split, I use the space separator. I use a empty space as a separator to separate out the words and return a list. But in this join operation, I will use a space separator and an empty space to combine the words in my review with a space and return a string. So it's just the diametrically opposite of split. Now I need to append it to my corpus. Now I'll run this for loop. So yeah, I need to run this file up. So yeah, this will take a tad bit of time because we are iterating over 2055 reviews, and for each review we are doing some processing. We are going through each and every word in our review. So yeah, our corpus is ready. So corpus is basically a text column from our reviews, but it is processed. As we can see, we have removed we have made it to lowercase, stemmed it down, removed some unwanted characters, and there are some empty strings as well, because like they were in Spanish, and when we passed them down to the stemming, it couldn't find a root word for that word, so it just returned an empty string. So there might be some unwanted or some fishy reviews, so yeah, we got rid of them as well. And now we'll start off with creating a bag of words model. So for that, we'll be using the count vectorizer class from sklearn. So I'll create an object of my class. So here I'll add an argument of max features, because as I previously mentioned, I want to just use a 1500 words that occur the most in my document, in my all of my corpus, in all of my reviews, because they are the only words that will carry an effect to the label. Like if I'm using this word is occurring most of the times, so that might add some meaning, or that might add some meaning. Yeah, that is either positive or negative. So I'll define my X, basically a 2D data set of my features. So I'll use the fit transform method. So basically there are two methods, fit and fit transform. So what fit does is, basically if I'm inputting my data here, like I'm passing down the corpus into this so basically it will learn what are the features, like the word dislike or like, some kind of these words that occur the most in the reviews. It will calculate all of those max features, and it will learn how to vectorize them. Okay, but it won't do anything. I'm talking about the fit method. Okay, so it won't do anything or return anything. It won't apply that knowledge that it has, what features that it has identified, what parameters that it has calculated. It will just calculate them, find them, and store that knowledge, that how to vectorize in its object state. It won't return anything or transform our corpus. But here we want our count vectorizer to find out the features and apply that knowledge to our corpus and return the count vectors for each of our reviews. So we are using the fit transform method. So now we'll define our label that either positive or negative, and that is basically the last column in our data set. see the sentiment. And basically, like what he'll do is select basically what we'll do is use the iloc method. Iloc is basically used for finding the data based on indexes of rows and columns. So for example, if I want all of my rows, so I simply just put a colon there, and if I want the last column, right, so I'll just put -1. So what it will give me, the sentiment column, just the sentiment column with all of the 2055 rows, but the sentiment column. So if I wanted just the first 5 reviews, so I would have written 0 to 5, and 5 is the upper bound. So we'll just find 0, 1, 2, 3, 4 indexes and just the last column, so just the label of the first 4 reviews. Similarly, we can do slicing and the column part as well. Like we wanted 2 to 5 columns. Okay, in all of the rows I just wanted 2, second column, third column, and the fourth column. So basically what it would return is a pandas data frame. A data frame is 2-dimensional while a series is 1-dimensional. So I'm just returning a column with all of the rows, so it's a panda series, but I need to convert into a numpy array or nd array. The type of a numpy array is nd array. Remember this, might be asked in your interviews. So yeah, so for that, pandas provides me a attribute called values, so it will just return a numpy array. And here as well, the corpus here, the fit transform method doesn't return a numpy array. To get a numpy array, I need to add this function toArray. So yeah, our X is created, are basically our features. So like we have 1500 words, you can see in the like 1500 columns and 2055 rows. 2055 basically my reviews, and these are 1500 words that occurs the most, and that actually make some contribution towards making the decision that whether it is a positive review or negative review. Now that's it for this video, and next video we'll learn what SVM is and what is the intuition behind it and how it can be used to classify our reviews by giving this count vectors that we have just created. So stay tuned for the part 3. Goodbye.